Hello, grade 11s and hyperbolas, which seem to be causing a few issues with some people, but some of you are getting into it quite nicely, and that's good, just to push yourselves. And we got a bit of time with this, so let's go through this. So we got some hyperbolas, and I'll go through the hyperbolas that you're enjoying and sending in, and from what I can see, as I said, some of you are really grappling with this nicely, using your functions knowledge and transferring some of it from parabolas, but let's get into it. F of x equals 1 over x. Well, let's make this big and hope that it records well. So this one we're going to be drawing in our sleep. This is our most basic hyperbola. And we're going to have our axes at the radii x, y, and draw our hyperbola. Where is it here? So our shape for the hyperbolas looks something like that in the first quadrant in the top right, and down here in the third, that is terrible, in the third quadrant down here. Okay, so on the bottom left. But that's not all for our hyperbola, because we can see if this is our function, we've got x in the denominator, so x can never be 0 because we can never divide by 0. So let's put this in here and go, let's put a dotted line all the way down here to go x equals 0 is an asymptote. It never reaches there because we can never input 0. So if we look here, we get closer and closer and closer and closer, but never quite reach there, and same on this side. And the hardy-does agree. So what else? There's another asymptote as well. Well, if we divide this, we can never get an output of 0. We can get closer and closer, but we'll never quite reach 0. If we put in a big number like a million, 1 over a million, tiny output. 1 over 100 million, still tinier, but never quite 0, and we'll never get this. So as you look along your graph here, it will never quite reach 0. So there's another asymptote that's along here, and we need to label it y equals 0. In other words, the output y is never going to reach 0. It's going to get closer and closer. And these asymptotes are important. They're going to be our guides for sketching our hyperbolas all the time. So we're going to put them down first, and from there it's going to be easy to sketch our hyperbola. So let's run through the hyperbolas that you were doing. So the first real one, well, the other one was real, I guess, but the first real one that will require a bit more is g of x is 6 over x minus 2. So we got our axes are going to be useful. X-axis, our y-axis carries on all the way. Let's look at the bits of our function that we're given. And let's give ourselves a bit of space here. We've got this minus 2. This is our q value. And the q value moves our graph up and down. We saw that with the parabola, where it was plus 16 and it moved up to 16 and the turning point was up there, or minus 9 and it moved down by 9. This is what our q is doing, is moving it up and down. And in this case, it's negative 2, so it's going down by 2. Let's actually pause on that and put that into our sketch. We knew that we had an asymptote here along the x-axis before, and everything's moved down by 2 in our graph. So now our asymptote's going to be along here, y equals minus 2. And you need to label it, so let's put it in straight away. So I said it's going to be our guide. Okay, what else have we got? We've got our value up here is our a value. Now a tells us in the parabola, remember it was two things. If it was positive, a nice happy parabola. And if it was negative, then a sad parabola. Similar with our hyperbola, except instead of happy and sad, let's just think about it. Is it that original one we knew, or is it reflected down? Because that's actually what's happening, not the happy or sad, but it's our parabola and reflected, or is our hyperbola reflected? This is a positive. So if it's positive, then it's going to keep its shape in the top right and the bottom left. So we know it's going to be here and here. And the last bit that we've got, which is going to be new, is our p-value. And the p-value is the one that's new this year, and that's what's moving or translating our graph left and right. Now, there isn't. It doesn't say x minus 3 or x plus 4, so our p-value is 0. But otherwise, it would be moving it left and right. It hasn't moved it left and right, so this asymptote is staying exactly where it was in our most basic graph at x equals 0. And now we're ready to sketch our graph. We know from our a value that it's going to be the top right and the bottom left. So let's draw it. Top right and our bottom left. Cool. And now it shows us that there is an x-intercept over here. We don't know what it is. We do know that it's positive. And in your parabolas you're drawing, some of you spent quite a while looking for x-intercepts that weren't there. Now we can see there is an x-intercept it's worth trying to find. Don't try and find a y-intercept because there definitely isn't one. So we know something about our x-intercept. We know the y value is 0. And this is where it's our same function knowledge coming back. If we're given one value, how do we work out the other? Well, we're given the output, so we're given that our output is 0, and we need to find out what the x value is. So 6 over x minus 2. We're trying to find x. Okay, so let's solve this. We've got plus 2, plus 2. So we've got 2 on the left-hand side equals 6 over x. Don't want this fraction, so let's multiply by x, because then we're going to cancel those. Well, what we do on one side, we do on the other. So we've got 2x on the left-hand side equals 6. Well, 2 times what gives us 6, 3, but let's actually run through and go, okay, divide by 2, divided by 2. So x equals 3. Okay, so there's our graph, and I'm just going to pause to get our video back. It seems to have lost it. Okay, so we should be back now. I'll say that, and then it's gone again. Okay. Okay, hopefully it stays with us with all those marks. I'll be honest that I recorded past this point and then lost everything and started again. Okay, so here we go. We've got x equals 3. Now, in some of your notes I talked about write down full coordinates, write down full coordinates. Because x equals 3, what does that mean? X equals 3 is actually a line sitting at x equals 3. What we were working out here was the x-intercept. We've said when our y was 0, our x was 3. So let's write it as coordinates over here. Yes, we're going to put it into the function, but let's write it there as well. So we know that 3, 0 is on our graph. So 3, 0, there it is, we worked it out. 3, 0, and our graph's done. As I said, we're not going to try and find a y-intercept because there isn't a y-intercept. So we're going to keep going forever. So there's our function. Let's scroll down to another one. H of x equals minus 12 over x plus 4. Okay. Hope you're pausing, giving it a go, and then continuing the video, because you should have everything you need to sketch this function. Okay, so we've got our axes, x and y, and we've got our hyperbola. Let's look at the things that we're given. We've got a q value of 4, so that means it must have moved up by 4. Let's capture that straight away. Asymptote, here it is, moved up by 4, it's sitting at y equals 4. A p value, p is 0, so we haven't moved left or right, so this asymptote stays exactly where it is, x equals 0. We've got an a value here, and our a value is negative, or a is less than 0. So that means that instead of it being in the top right, bottom left, it's been reflected, so it's going to be in the bottom right, over there, and on the top left. Okay, now that we've got our picture, we can see there's our x-intercept. Looks like a positive x-intercept. We know that the y value is 0, so we can run through and we can go, great stuff. 0 equals minus 12 over x plus 4, and therefore determine what it is. I'm going to do it a quicker way, which you're welcome to do, or you can run through all those steps and go, this part here must be negative 4. So negative 4 plus 4 gives us 0, which means x should be 3. Because negative 12 divided by 3, that's negative 4. Negative 4 plus 4 gives us our 0. And let's sum it up, 3, 0. So there it is, 3, 0. Okay, great stuff. Let's head on to the next one. Okay, something looks a bit different here. Let's have our axes ready to go. X-axis, our y-axis, and what have we got here? Okay, we've got our Q value. Q is 0. So in other words, we haven't moved that original graph up or down. So let's put this asymptote in straight away. Y equals 0. There's our asymptote. P. Here's our P value. And remember with that X with the parabola, it kind of did the opposite. So it was a +2 and then the +2 for the parabola. Similarly, it moved left by 2. Instead of, you'd think +2 would be moving it right, but it moves it left by 2. So let's move this asymptote and let's move it left by 2. It's almost like this, but here our turning point is -2, 0. It's not a turning point, but that's kind of that crucial point, like the parabola, that interesting point. So we got that, and let's label this y equals -2. I said y, I guess that should have been x. X equals -2. Relates to the x and kind of does the opposite. And our last bit is this part here, our A. Our A is positive. If it's positive, then we know it's going to be top right, bottom left. So we know that it's going to go over here. Let's draw it over there. And carrying on there. And bottom left. And that's because this A value over here is positive. So it's still going to be that top right, bottom left. We can see that there's a y-intercept. We can see there are no x-intercepts. There's an asymptote here. It gets closer and closer, closer and closer. Right, so let's find out what this value is. Well, we know that this time its x value is 0. So let's substitute. We're looking for the y value equals 1 over 0 plus 2. So y equals 1 over 2. And by saying, let's just sum this up, especially when there's more involved question, when there's lots going on. We said when x is 0, y is a half, and let's put that into our graph. Okay, that leaves us with one last function to do, where we're going to have a p value and a q value. Okay, let's go ahead and do it. K of x, we're given. Let's have our axes ready. Let's run through this steadily. X, y, axis, axis. Okay, so let's start with our p value. P is here. Sorry, our q value. Let's start with our q. Our up and down, because that's what we used to use before. So let's start with that. Q value is 10. It's a positive 10, so it's going to move it up by 10. So our asymptote that was here has moved up by 10. And y equals 10. Okay, our p value is what relates here. And our p value, it's -3. Remember, it kind of does the opposite, so it must be +3. So we're going to move this. It doesn't have to be perfectly to scale, but I shouldn't put it all the way out here. It's going to be somewhere about there. At least that's about 3 and that's about 10. Not perfect, but at least it's close. Okay, we can label this top or bottom. I tend to put them here. X equals 3. Okay, and our 12, our A value. A value here is positive. If it's positive, then it's like that original graph. It's going to be top right and it's going to be bottom left. So it's going to be top right. So it's going to be here. And it's getting closer, and it's going to be down here. Okay, now it looks like we've got an x-intercept and a y-intercept. So let's label these, or put our points in. Let's start with the y-intercept, just because it's normally a bit easier to find. For our y-intercept, our x is 0, so we're going to substitute that in. I'm going to say the y-int is what we're trying to find. We're putting in k of 0. Our input is 0. So 12 over 0 minus 3 plus 10. 12 divided by -3, -4, -4 plus 10, +6. Of course, you can just punch it into your calculator. And what we were finding out again, oh yeah, we said when x was 0, y is 6. Let's put that into our graph. Okay, then we need to find out our x-intercept. Now for our x-intercept, our y value is 0. Let's give ourselves some space here. So 0 equals 12 over x minus 3 plus 10. Okay, so let's do this. Minus 10 equals 12 over x minus 3 multiplied by x minus 3. So we're going to have minus 10x plus 30 equals 12. Notice that you're multiplying x minus 3, that whole thing, by minus 10. So that negative, that was a positive. Okay, I'm going to go minus 10x, subtract 30 from each side, gives us minus 18. Okay, let's move up here. Obviously it should have a bit more space, but I want to just keep everything here on the same screen. And we've got divide both sides by negative 10, so x equals positive 1, 8, or as a fraction, doesn't really matter, and we're going to have 1, 8 over there. Let's just check that out actually quickly. 12 divided by 1, 8 minus 3 plus 10 equals 0. Okay, so I've just substituted this back into the equation just to double check it. Okay, then we're good. We've got 1, 8, 0, everything's in our graph, everything fitted, and the starting point was just thinking, what was that starting point of that graph? What does 1 over x look like? And then transforming it from there. You've got q is always moving it up and down. P is the new one, it's moving it left and right. And then the a value, well, it's stretching it, but almost more importantly, if it's positive, it's kind of what we expected, and if it's negative, it's going to reflect it. So now that you've got that, just going to do 4 more. So just 4 more, run through that process. Think about what your q value is, your p value, your a value, and just run through that process and slowly but surely go for it. So I have all faith in you. Go for it. Good luck. Have fun.